Good afternoon, good morning, everybody. We will go ahead and get started with our August webinar. We're happy that you have given us the opportunity to present the webinar this month. And so we'll go ahead and get started. So this month we will focus on the plastics application, and we will take a look at the impact of both chemistry and finishing on the plastic performance. So we are recording this webinar, so all of those that are in attendance will receive the link to the recording and the PDF of the presentation as well. And please feel free to share that within your organizations to any others that might benefit from this. And if you have any questions, go ahead and use the chat box, and I'll address them at the end. However, if that's not your thing, that's okay. Just send me a note outside of this and I'd be happy to help. So with that, we'll go ahead and get started. I'm going to turn my camera off just so that it's not as distracting for myself as I go through this. Okay, so we are going to, so with colorants, of course, there are pigments and dyes, and all of these, there we go. All of these are used in plastics. And however, in today's webinar, the work that we put into this presentation will really just be focusing on just the organics, as we wanted to understand a little bit more about chemistry and finishing of organics and in plastics applications. So with that, we'll go ahead and move forward. And we've talked about this in the past before, where a pigment is only technically valuable to a customer if it performs in the right manner for the specific application that it is intended for. And even in the applications area of plastics, there are many different unique market segments that have to be understood, and each of those also has some unique technical requirements that have to be met. So in the color selection process, obviously taking a look at what kind of color and effect you're trying to achieve is one of the first areas to address. However, right after that certainly is the application area. What kind of polymer are you going to be using? What kind of heat stability profile does the colorant need to withstand? What other types of additives or ingredients are in the formulation that might cause an interaction with the pigment? And of course, whether or not it's going to be an interior or an exterior type of application. So we need to understand what kind of light and weather fastness requirements are needed for that colorant. And obviously then technical performance needs to be understood as well. Things like migration resistance or dispersibility, particle size in terms of film transparency are just some of the many types of technical properties that have to be considered when selecting a pigment. And then, of course, because there are some applications in plastics where there is a need to have additional compliances like food, toy, and medical that have to be considered when selecting that particular colorant. And last, but certainly not least, of course, is cost. And cost is just that, the dollars per pound of that particular pigment. However, there's also a value to be considered. For example, you might select a higher cost per pound pigment in order to gain significant amounts of additional technical performances, which then can lead to more sales on your part because of that additional technical performance. So there's many properties that are present with respect to colorants. Just a number of them are listed here, and each of these are going to have some amount of impact on the performance areas. I've highlighted here the ones that I thought were the most prevalent with respect to plastics, and how those will end up, could end up in impacting the final performance of the plastic part. So as a pigment supplier, Sudarshan makes all types of grades of pigments, and those pigments are designed for certain applications like plastics, coatings, and inks. However, it's not to say that they will necessarily not work in all applications. So there is a fair bit of crossover between the grades, and our job here is to help you match the right product with your application, regardless of what grade it was designed for. However, in general sense, pigments that are developed for plastic applications are typically cleaner in terms of their formulation. They are softer and smaller in size because we need to have improved and efficient dispersion. The extrusion process of a plastics has a very short residence time for the dispersion. And so we need to make sure that the pigments that are chosen for that application are as dispersed as possible in that short residence time. So we'll start out by going back to something we've seen before in past webinars, where we're taking a look at the difference between classical and high performance pigments for a plastics application. Of course, the key difference here is in the heat resistance, where classical pigments tend to have a much lower heat resistance profile than the high performance pigments. There is one class of pigments that sort of fall in between, and these are the blues and greens. Traditionally, we put them in the classical type of category because their chemistries are older, they are a little bit more simpler. However, they do have a lot of properties that are very similar to the high performance pigments, but in most cases they are priced more like classical pigments. So I've added a kind of an in-between category for blues and greens. And naphthols also tend to fall in the in-between area as well. So as a pigment supplier, we do know that we generate about 75% of the pigment performance solely on the chemistry of that particular pigment. And then the remaining comes from the finishing and the surface treatment. And in reality, the finishing and surface treatment that we employ onto each product really just alters or moves the pigment performance in one direction or another. However, we can move a pigment from a not a good application to an okay application just by manipulating what finishing and surface treatments that we use in that particular pigment. So it's, as far as finishing techniques, there are 4 places where that finishing can be used and impact the final performance. The first area is in any kind of surface treatments or additives that are used directly after the crystals are synthesized in the reactor. Once the crude is completed, and the synthesis is finished and the crystals are grown to their appropriate size and shape, then in the dryer we have options in drying method to choose from to be able to dry the bulk of the water from the product. And it's the choice of dryer which dictates how hard the pigment might be in the end. So many choices of dryer type. Next is we have the choice of further milling the product. And here we have the option to alter the particle size and particle size distribution for those for that product. And then lastly, each of the batches of pigment that are created, they are then blended into the final lot. And it's at this blending stage where we have the option to use additional additives that are designed for that particular product. So as far as plastics are concerned, a great testing to understand how easily dispersed a pigment might be is the filter pressure value. So this determines what the impact of any oversized particles might be in terms of how well the dispersion is. And so it's also used as a QC test for understanding which products are appropriate for film and fiber applications. But overall, it's a great test to understand and compare product grades in terms of how well they will disperse. And it's reported in terms of the bars per gram of pigment in this particular test method, but it's also important to acknowledge which size screen is being used in this particular test. In these examples that I'm sharing with you today, we are using the 25 micron mesh screen in the filter pressure test. So in the work that we did to present this webinar, we selected a number of chemistry pigments and also a number of grades within that particular class of pigments. And we ran each of them through the filter pressure value test method, which is simply a small lab scale extruder where the material is sent through the extruder and passed through the appropriate die. In this particular case, it's a 25 mesh screen that it is passed through. As I mentioned before, a number of physical properties of the pigment can impact the dispersibility of the pigment. These are the ones that are most important with respect to plastics for dispersibility. So overall, here's the types of chemistries that we explored for this webinar series. We took a look at a number of high performance pigments, which are on the left-hand side of this chart. Yellow 110, orange 64, violet 19, red 122, yellow 180, and yellow 138. On the classical side, we took a look at a couple of reds, the red 53-1 and the red 57-1. And then, as I mentioned, that in-between zone of blues and greens. In this particular case, we took a look at the pigment blue 15-3 and the green 7. And in each case, you can see where we've chosen a selection of different grades within each chemistry. So we tried to choose some from plastic side, of course, coatings and inks wherever we could, so that we would have a cross section of finishing types to compare in each of the chemistries. And so overall, what we see here, using the filter pressure value as a measure of dispersibility within the plastics world, we see that the high performance pigments on the left-hand side all have, or pretty much all have, pretty good and low filter pressure values, although there is a variety within each chemistry. And there's also a quick snapshot as to which grades are appropriate for fiber and which may not be. For example, violet 19s overall are probably not a great choice for fiber applications because they have higher FPV values than are required for a fiber application. And likewise, over on the right-hand side, we took a look at the blues and greens, that intermediate zone, as well as the classical pigments. And we'll come back to this chart again when we take a look at some other examples. So as the name implied, we wanted to take a look at properties that are related to both chemistry and finishing. So when we analyze all the information that we generated through this exercise, we determined that heat stability, filter pressure value, which we just saw, warpage and migration are the key areas from a performance perspective that are solely related to the chemistry. It's that 75% performance criteria that we know impacts it from the chemistry perspective. So the following examples will demonstrate that. So heat stability, of course, is expressed as the maximum temperature over a 5-minute dwell period, such that the delta E, or color shift, is less than or equal to 3 in terms of that. And here's some specific information about how we test it. I'm not going to go through the details there, but when we go back to that chart of all of the chemistries that we took a look at, again, on the left-hand side is all the high-performance pigments. And overall, we can see a big difference between the high performance and the classical, which we mentioned earlier as being the key difference between the two groups of pigments, where the high performance pigments have a higher heat stability rating versus the classical. However, in between, within each chemistry, the different grades do present themselves a little bit differently with respect to heat stability as well. As I mentioned, the blues and greens are in that in-between. They tend to have a lot of properties that look like high-performance pigments, and heat stability is one of those properties where all of the blues and greens in the study have very nice heat performance. However, from a pricing perspective, they do look more like the classical pigments. Next, of course, going back to that fiber application by chemistry, we return to the FPV value. And as I mentioned earlier, as a chemistry, violet 19s are not an appropriate chemistry for a fiber application, because all of these examples here have a FPV value greater than 2, which is what we use as a general cutoff point for pigments that are appropriate for fiber. And whereas the rest of the chemistries in high performance area do have products available that will be appropriate for fiber. In the classical sense, there are in these particular examples, of course, there are less options, and in the blues and greens, we do have options for fiber applications. Warpage is another area where the chemistry has a large impact on whether it will be appropriate or not for this particular type of technical property. And when we want to understand how much the shrinkage is impacted by the pigment, we do measure the warpage. These are recorded as notes 1 through 3, where a rating of 1 is suitable for that application and that technical property, and a rating of 3 is not suitable, where there's more than 20% of a shrinkage that is impacted by the pigment. So going back to our chemistry choices, we see here that on the high performance side, pigment yellow 110 is not an appropriate chemistry for this particular technical property. However, the remaining high performance pigments in the study have a very good response to warpage. Over on the classical side, here's an example where that in-between grouping of blues and greens tend to act more like the classical pigments in that for this particular property where the blues and greens in this study are not appropriate for this particular property. And of course, the two classical pigment chemistries that we included in the study are also not appropriate. Migration is another property where we found to be directly related to chemistry for the most part. And this is also given a 1 to 5 rating based on the grayscale. So that we can assess how much staining is achieved with that particular pigment. So in general, here are some chemistries that have a good response as well as a poor response to migration. However, the chemistries that we've chosen in this chemistries and products that we've chosen in this particular study all had a very good response to to migration. So there's not really a good correlation here in the study that we've chosen or the chemistries that we've chosen in this particular example. Although we do start to see a little bit of differences in a few chemistries that may give some pause, especially we start to see some differences within the pigment blue 15.3, where we go from a very good response to slightly less than good response. Moving over to the finishing side, there also are a number of individual properties as well as some of the main properties that we talked about that were solely chemistry related. But now we can go a little bit further and look at the different finishing techniques and how they are impacting the final applications. So filter pressure for fiber applications, which we've seen a few times already for the chemistry part. But when we take a deeper look into the chemistries, we can see how the fiber applications can be impacted by choice there. A subset of fiber is film, and there we take that to the next level and be able to compare the finishing techniques and how they impact that application if you need to have a film made, because not all products that are okay for fiber are okay for film. Heat stability, of course, is also can be distinguished within the chemistry based on the finishing techniques, and then color strength and color shade are also driven by that finishing steps at the end. So what I've done here in each of these application areas, the examples that I've pulled together, I've tried to bring a high performance example as well as that transition blue-green. In this particular case, I've chosen the Pigment Blue 15.3. And I've also chosen a classical example so that we get a nice round look at the different types of organic pigments and their responses within each of these categories. So first up, of course, is fiber application. And in this particular case, we're looking at the red 122. In our study here, we chose a plastic product, a coatings product, and an inks product. And in this particular case, we definitely see where the techniques that we've used to create the plastics product, the 2991, definitely offer a very good choice for a fiber application. However, as we move over to the needs for a coating application and the needs for a ink application, these tend to require additional surface treatments and other finishing steps that are needed for that particular application and formulations within the application. So they tend to bring in more complexity onto the pigment surface, which obviously interacts with the polymer and disturbs the amount of dispersion that is able to achieve with this particular chemistry. Moving into that in-between period for the blue, the Pigment Blue 15-3. In this example, we chose 5 actual products, 1 plastics, 2 coatings, and 2 inks to demonstrate the finishing differences here. And in this particular case, the finishing steps that we imparted on these 2 coatings products does not impede the ability to have options for a fiber in this particular case. So all 3 of these products are acceptable to be used in fiber applications. However, again, the 2 ink grades, these are 2 very different ones. The 2779D was designed for a solvent-based ink systems, and the 5301D was designed for inkjet type grades, so water and UV applications. So the finishing steps required for each of those applications then are obviously impeding the amount of dispersibility for those particular 2 products. On the classical side, here I chose the red 57-1 as the example. We've got 1 plastic products and 2 different ink products. And the same can be said here, where we have a good product on the plastic side for a fiber application, and we see very big differences between the 2 ink grades about how the finishing techniques that were used for each of these products impact the dispersion. Film note, as I mentioned, film note is a subset of fiber. This particular application takes it to the next extreme in terms of dispersion. So we take a look at what's called a film note rating, of course, where we rate it from a 1 to 5, with 1 being no undispersed pigment particles in a length of blown film, and 5 being more than 15 particular particles that are counted in that length of film. So from a film note perspective, I chose a couple of examples to demonstrate here, Pigment Yellow 138 and Pigment Blue 15-3, where there were a number of good examples that can be used for fiber. And then the differentiation comes when we take it to the next level in film note. So for example, in the Pigment Yellow 138 area, they both were very good for fiber, very low FPV value, but we start to see a difference in between in the film note where the number of particles, undispersed particles, is a little bit higher in the coatings grade than in the plastics grade. And the same can be true with the Pigment Blue 15-3, where we saw that there were 3 choices, 1 plastics and 2 coatings grades that were okay for filter pressure value for fiber applications, but we again start to see some distinctions when the application is much more stringent with respect to film. Moving on to heat stability. So in this particular case, I chose the Violet 19 as the example in the high performance area, where we had 4 product grades in the study, 2 coatings, 1 plastics, and 1 inks. In this particular case, we have both a plastics grade and a coatings grade that goes all the way out to the 300 degree C measurement for a delta E of less than 3, which is signified on the chart there. And then the other two grades are slightly off at about 270, 280 degrees C. So not a huge amount of difference, but we start to see where the finishing techniques that are used can start to impact this particular property. Moving into that Pigment Blue 15.3 space where we had the 5 products. In this case, as an earlier chart has shown, all of the products meet the 300 degree delta E of less than or equal to 3 mark. However, we do see that the plastics grade and the 1 inks grade does have a better response than the other 3 grades in this particular fashion. On the classical side, I chose the red 53.1 space for this particular example. Here, 2 plastics grades and 1 inks grade. Although in general, this will have a much lower heat stability response, we do start to see a difference between even the 2 plastics grades, where they have a slightly different. One has a slightly different, slightly lower grade temperature than the other. The ink grade in this particular case is very similar to the plastics grade as well. From a coloristic perspective, of course, we always take a look at the color shade and the color strength, and primarily differences are always going to be dictated by the finishing steps that are employed for that particular grade. So in terms of strength is concerned, I took a look at the orange 64 as the high performance example. And in this case, this is our tint tone color perspective, where the size of the bubble is the L value. So that's an indication of the strength in these examples. So the higher the L value signifies a lower strength when all 3 are compared together. So what we see here is that the 1 plastics grade and the 1 coatings grade have a relatively similar strength to each other. However, the 1 plastics grade is going to be on the weaker side when all 3 are compared together. In that Pigment Blue 15.3 space, where we had 5 product grades in the study, we see that the 1 inks grade, of course, is going to be much weaker than the other 4. And then within that remaining group of 4, the other inks grade is going to be a little bit weaker than the 2 coatings and plastics grades, which are all very similar to each other in terms of strength. And then in the classical size, the red 57.1, where we had 2 inks grades and 1 plastics grade, we see that the plastics grade actually is on the weaker side in comparison between all 3 taken together. And one of the inks grades shows up to be a stronger product in this particular evaluation. Moving over to color shade. In this example, I took a look at the violet 19s and where we had 4 products to consider. For the shade, a violet 19, this is the gamma crystal, so we want to see the color development towards the red, of course, side, but also to the yellow side because it is the gamma crystal. So what we see here in terms of color development, one plastics grade develops much more red and yellow than the other grades. However, the one's coatings grade is very similar in terms of its yellowness development in this case. And then the opposite, of course, is true with the inks grade, where it does not develop as much yellowness as the other products in the study. In the Pigment Blue 15.3 space, where we had 5 products in the evaluation, here we see the one inks grade that had some lesser properties in other areas, also provides the most green color shade in this plastics operation or evaluation. So for the Pigment Blue 15.3, we want to develop as much green value because it is the beta crystal in this particular case. So overall, the couple of the plastics and coatings grades that do develop the most blueness, of course, with this area, but they don't necessarily develop the most green. And then lastly, on the color shade for the classical pigment area for the 53 red 53-1. Here we see both plastics grades developing the most red and the most yellowness, which is the direction a red 53 wants to go in terms of color development. So these are always going to be a balance, and we, every webinar I seem to use this particular chart because it's a very important chart to understand and to consider when selecting a pigment for your application. You're always going to need to balance your pigment chemistry and finishing, which gives you the ultimate performance with your application. So it's important when you go into selection of a pigment that you have a nice list of your must-wants and nice-to-haves. Of course, in that must category, you're also going to prioritize those musts because there is not a perfect selection of pigment that you can choose from. So there's going to have to be a balance in some areas. So in doing so, what I did was I tried to, since I've offered an evaluation of different grades, whether it's an inks grade or a coatings grade or a plastics grade. I wanted to go through this exercise with you in choosing what might be an appropriate pigment choice for your application. So I've chose 3 chemistries to take a look at, and diving a little bit deeper down into performance and how to select the best option for your need. So the first one I'm doing here is the Pigment Red 122. And in this particular evaluation, we had 3 examples that we included. So the first question to ask yourself is, what is the application? If it's fiber, really there's only one choice. Out of the 3 products that we included, then that's the plastics grade. However, if you have a non-fiber applications, all 3 products will fit this particular need. And then it's a deeper dive into each of the technical properties. If it's heat stability, then we have 2 options, the plastics, of course, and the inks grade were very good in this particular property. Warpage, all 3 fit the bill. Migration, again, all 3 fit the bill. Strength, we saw that the plastics grade was appeared to have the highest response there. Color shade. For a red 122, typically we want to develop the color to the blue side of the space. However, if you're looking for the bluest grade, maybe the plastics grade is your choice. However, if you're looking for a more yellow grade, the inks grade that we included showed to be the yellowest. So again, it's going through this exercise that is key into selecting the best product for your need, not necessarily because it's in the plastics bucket of products that that we have to offer. Continuing in the theme that I've used throughout the presentation, taking a look at the Pigment Blue 15.3. Again, the same process. What is your application? If it's fiber, you have 3 out of the 5 products that we looked at are options for you. Then again, just like we've done before, it's a deeper dive into that application area. If it's going into more of a film property, your best choice is the plastics grade, the 2789. There's a typo there. If it is heat stability, the 3 grades that are appropriate for fiber are also okay. Warpage, unfortunately, there appears to be no option in this particular case. However, it's fiber, so warpage may not be an appropriate topic for a technical property for that application. Migration, plastics is the best choice. Strength, all 3 were equal. And for color shade, in this particular chemistry, we want to develop the most green. So the coatings grade happens to be the greenest in this particular fiber application. Flipping over to the non-fiber, where you have all 5 products are appropriate. All 5 products, of course, will meet your heat stability needs. From a warpage perspective, we start to see where this inks grade shows a little bit of promise with respect to warpage. It's mid, it has a mid rating for this one. Migration, we saw that the plastics grade was the better performing. Strength, they were all equal. And from a color shade perspective, where we want to develop the greenness of the pigment, the inks grade turned out to be the greenest of the 3. And lastly, jumping over to the classical grouping of pigments, here I chose the Pigment Red 57.1. Similar idea here. If it's a fiber applications, you really only have the one option, the plastics grade, for that fiber because of the FPV value. All 3 are appropriate for a non-fiber application. Taking it a little further into heat stability, the plastics grades did have the highest response there of the 3. In terms of warpage, none of the options was a very good option for this particular method or property. From a migration perspective, the plastics grade was a better choice. Strength, the one of the inks grade was the better choice. Had the highest strength area. In the color shade, here we want to develop the blueness of the chemistry, and this particular inks grade was the bluest of the 3. So it is this area where we like to be able to help all of our customers in determining the best product for the actual application need, not just necessarily the plastics grade for that particular chemistry. There might be something else out there that gives you what you're looking for. So we've been busy this month. We've launched a few new products, 2 products in the Pigment Red 122 space. We've just recently launched our Pigment Sudarshan Pink 2991K. This is another option for plastics, which offers excellent FPV for fiber and film applications. The other Red 122 is in our inkjet brand, our Sudarshan brand. This particular product was developed primarily for inkjet water-based and UV types of formulations. This particular product does offer excellent stability and low viscosity for those types of applications. And then lastly, our third product that we're launching this month is in the Pigment Violet 23. So this is a second product in the Violet 23 chemistry that we've launched this year. This is our Sudaperm Violet 2946K. This offers a more red shade option in the Violet 23 space. It is also excellent for fiber and film applications. So another addition to our Sudaperm brand of high-performance pigments. So our team is here to help in any way that is needed, and we'd be happy to help. So if you have any questions or need any samples, feel free to reach out to any one of us. We'd be happy to help. So we're going to take off the month of December from the webinar series as we did last year because we're going to be busy with 2 shows. In September, we're going to be presenting at both the Powder Coating Summit that's going to be held in Chicago, and also the CAD Retech, which is going to be in Orlando. So we hope you can join us for either or both of those shows and join us for the presentations as well. We'll pick up the series again in October, where we're going to take a look a little bit at color design by applications. And so that'll be held on October 25th. So take a look for that invitation at that time. And then we'll round out the year in November, taking a look at mica surface treatments for long-term durability. And that'll be in November. So I just wanted to thank you for joining us today for this webinar. I know summertime is really rough for getting into all the things that you want to do, so we appreciate your time. And I would like to open it up to any questions that you might have at this time. And so if you do have any questions, feel free to enter them into the chat box. If not, you could always send me a note directly, and I can answer it that way. Okay, well, it doesn't appear that there's any questions, and so I really like to thank everybody for joining us, and we do look forward to seeing you again in October, and we also hope that we see you at either the Powder Coating Summit or at the CAD Retech shows. So thanks again, and enjoy the rest of your day. And we'll see you again in October. Take care, everybody.